Hi, I'm Dr. Robert Cohen. Today I'm going to show you how to solve a pretty popular SAT and ACT math problem where they give you the sum of a arithmetic sequence and they then ask you to find the terms in that arithmetic sequence. First of all, if you don't know what an arithmetic sequence is, go check out my video on arithmetic and geometric sequences. But I describe it in detail. I'll just describe it briefly here. In an arithmetic sequence, it's a sequence of numbers where you start with one number and you add the same number over and over and over as you move along the sequence. So you start with 1, add 1, you get 2. Add 1 again, you get 3. Add 1 again, you get 4. Down here I've done the same thing, but I'm adding 2 this time. 1 plus 2 is 3. 3 add 2 is 5. 5 add 2 is 7. So it's a series of terms that are evenly spaced, basically. There's a set amount. There's a set difference between each of the terms. A difference of 1, a difference of 2, could be a difference of 100, 100, 200, 300. So now this is what one of these problems is going to look like. They're going to give you the sum of a sequence. They're going to say there are 3 terms that add up to 60. They'll say like there are 3 consecutive integers that add up to 60. And consecutive integers, that's just an arithmetic sequence like we see 1, 2, 3, 4. You're adding 1 each time to make them consecutive. So consecutive integers, again, are just an arithmetic sequence. So they'll say 3 consecutive integers add up to 60. What are these 3 integers? And what you could do is you could say, well, I have 3 integers. I make 3 slots. The first I'll call x, the second x plus 1, and the third x plus 2, because I'm adding 1 each time. This is like 1, 2, 3. Right? Then I add these all together. X plus 1 plus x plus 2 equals 60, because when I add them together I get 60. They add up to 60. And I can just do this equation here. 3x plus 3 is 60. Subtract 3 from both sides. 3x equals 57. Divide by 3. X equals 19. Then I draw out my 3 slots again. This is x. X is 19. This middle spot is x plus 1. 19 plus 1 is 20. The third spot is x plus 2. 19 plus 2 is 21. So now, using algebra, in the x variable, I figured out what 3 consecutive integers add up to 60. You can do that, but I'm going to show you a quicker way to do this, a little shortcut. So instead, you divide the term, right, by the number of terms that add up to it. So what 3 consecutive integers add up to 60? I divide 60 by 3, and I get 20. And I can fill each of my 3 slots then with 20. So if each of these 3 numbers were 20, they would add up to 60, right? 20 times 3 is 60. 20 plus 20 plus 20 is 60. So again, divide the sum by the amount of terms that add up to the sum. All right? And now we know that these 3 terms need to be consecutive integers. So here's what you do. You keep the middle term, the middle value the same. Keep it 20. But then I'm going to make this term 19 and this term 21, and now I have 3 consecutive integers, 19, 20, 21. And what I've done mathematically is these add up to 60. They add up to 60 just like 20, 20, and 20 add up to 60. And they do so because all I've done, I've taken a 1 from this 20, and I've moved it over to this 20. I subtracted a 1 from the 20 here. That got me 19. And I added that 1 over here to this 20 to get 21. So now I know really quickly what my 3 consecutive integers are that add up to 20. And this It's a lot quicker than doing this. So let's do this once more, but let's do it with non-consecutive integers. So evenly spaced integers, again, still in arithmetic sequence, but they're not going to be consecutive. So the problem might give us a triangle, and it might say the angles of a triangle are, the angles of this triangle are each 20 degrees apart. So 20-degree difference between the angles of this triangle. What are those angles? So to start, we find the sum of the three angles, and we know that the sum of the interior angles of a triangle is always going to be 180. The three angles always add up to 180. So I write down 180, and then I draw my three slots, because there's three terms that add up to 180. So now, again, we divide the sum, 180, by the number of terms, 3, 1, 2, 3, and we get 60. So let's fill each slot in with 60. And this is again telling us that if each of the three terms is equal to 60, they'll add up to 180. And now all we need to do is, we're going to draw three slots again, keep the middle term the same. And now let's think. Each of these terms is 20 degrees apart, right? So it's an arithmetic sequence where you're adding 20 each time. You're increasing by 20 each time. So all I need to do is make the first term 20 less than the middle term, and the third term 20 more than the middle term. 40, 60, 80. Now I have three terms that are each 20 degrees apart, or 20 apart, and they add up to 180. And again, the math works and they add up to the same thing that these add up to, because when you're making them evenly spaced, you're moving 20 degrees from the 60 on the left over to the 60 on the right. So 60 minus 20 is 40. Then I'm basically adding that 20 back over here, 60 plus 20. So they're still going to sum up to 180. So this works for any arithmetic sequence, whether they're consecutive integers, 19, 20, 21, or whether they're spaced apart by more than one, by something like 20, or by something like 10. Doesn't matter. You just divide the sum by the number of terms, keep the middle term the same, right? And then you make the other terms just spaced away from the middle term by the amount that they're supposed to be spaced. So if there were a 10-degree difference between these angles, then what would this be? Let's look at that. Well, we would say we would keep the 60, right? And then we want to take 10 degrees off this 60 to make it 50, and add 10 degrees here to make this 70. So if there were a 10-degree difference, your numbers would be 50, 60, 70. So this is really fast again. And just to show you the algebra, you could again use this method where you say I have x is my first term, x plus 20 is my second term, x plus 40 is my third term, right? Because we're adding 20 each time. So by the third term, you've added 40 to the original term because you've added 20 twice. And then if I add these all up, I get 180. So 3x plus 60 equals 180. If I just solve this, I subtract 60 from both sides. I get 3x equals 120. I divide both sides by 3. I get x equals 40. I draw out my three slots. The first is x is 40. The second, x plus 20, it's 60. The third, x plus 40. 40 plus 40 is 80. 40, 60, 80. So I get the same thing, but it's a lot longer. So you're going to want to use this method. Again, you take the sum they give you, you divide by the number of terms, leave the middle term the same, and then just space the terms to the left and right of the middle term using whatever spacing they tell you. If it's 1, space them out by a difference of 1. If it's 20, space the terms out by a difference of 20. These problems get a little bit more complicated if you're not dealing with a middle term. most problems you'll see, the vast majority, have a middle term. They give you an odd number of integers, like 3, and so there is a middle term. But what if they give you 4 terms, right? So there's no middle term. So here's what you do, and it's up to you in this case whether you want to do this method or just solve it algebraically. So what you do, you take the sum, again divide by the number of terms. So let's say here they'll tell you 4 consecutive integers add up to 62. What are those 4 integers? So I take the sum, divide by the number of terms, 4, I get 15.5. 15.5, I write it out 4 times in my 4 slots. It sums to 62. I draw 4 new slots. And what I do is, for the middle 2 terms, I need 2 terms that are each 1 apart from each other, and their average needs to be 15.5. So with consecutive integers, that's pretty easy to do. It's just going to be 15 and 16. Their middle or average is 15.5. Then again, I subtract 1 over here, I add 1 over here. I'm just making it so that they're consecutive integers, and they're going to add up to 62. And I've solved this. A little more tricky. Let's say they give you 4 integers, each spaced 5 apart, that add up to 50. What are those integers? So same process, 50 divided by 4 is 12.5. So I write out my 4 terms, 12.5, okay, 4 times. Now, the middle 2 terms need to be 5 apart, right? Because each term is 5 apart from the other terms. So they're 5 apart, and their average has to be 12.5. So an easy way to do this is you can say, how far apart are they? 5. Divide 5 by 2 and you get 2.5. Then you add 2.5 to this average value. Add 2.5 to it and you get 15. Then subtract 2.5 from it and you get 10. So 10 and 15. And that gives you the 2 values, 5 apart from each other, whose average is 12.5. And then we can just finish this. Okay, sorry, that's my cat. So then we can just finish this by subtracting 5, right? And then adding 5 on this side. And we get our 4 terms, each spaced apart by 5, that add up to 50. So at this point, it's up to you whether you want to use this method or just solve it algebraically. This method is still pretty quick. But again, most of the time, you'll see 3 terms, so you won't have to figure out, do this extra step here of figuring out what 2 terms take this value as their average.